Hello guys, this is me again. Now today I want to do some revision on equilibrium with you because equilibrium is a very important question. It's a very important area that always appears in exam every year. So before that, I want to I already gave you an equilibrium question yesterday. I hope you have already tried it. Before that, I want to make some points with you, okay? So equilibrium, I think everybody knows because we learned this topic in IGCSE, right? So the most important point is you have to know the Le Chatelier's principle, all right? Le Chatelier's principle. So do you still remember? It means when an equilibrium is attained. Of course, when you're talking about equilibrium, we are talking about reversible reaction, right? When an equilibrium is attained, then if you applied a disturbance, okay, the system doesn't like it. It will oppose it, okay, by shifting the equilibrium position to a new one. Okay, for example, the easiest example I show you is this one. If I increase the, for example, if I decrease the volume of the container, then what will happen? What will happen to the equilibrium position? Now, if you decrease the volume, the pressure will increase, right? Common sense. This is physics, okay? So when the pressure increased, altogether gas, right? There are two gas molecules and there is only one. So when the pressure increases, the equilibrium position will shift aside, okay? Shift aside with fewer gas molecules, okay? So, and then in this way, we will know that the equilibrium position will be shifting to the right because there is only one gas molecules but two here, okay? This is the first part. The second part is the calculation. For example, if we look at this one, then the Kc will be equal to C over A and then B, right? Of course, the coefficient, okay, of the equation will be the power. If the coefficient is 2, then you have to write 2. Okay, this is equilibrium. Okay, and then of course we have Kp as well. That will be the partial pressure of C at equilibrium over the partial pressure of B times the partial pressure of A. Okay, I will find out some questions and practice how to use these two equations with you. Okay, 好，那 then we go back to the question first. Okay, we need to go back to the question. Okay, this is the question I gave you. In an experiment, 2 mole of SO2 and 2 mole of O2 are allowed in a closed container. We know that only a closed container the equilibrium can be attained. Okay, so at this temperature. So when the reaction attains equilibrium, 1.8 mole of SO3, this is SO3, will be obtained. What's meant by the term dynamic equilibrium? Dynamic equilibrium, you can say that equilibrium, okay, the number of all species remain constant, right? And then at equilibrium, the rate of forward reaction will be equal to the rate of backward reaction. Okay, you know that, right? Oh, and then take a look on this one. Copy the equation here first. Remember, you check if it is homogeneous. Only homogeneous equilibrium will all the things be included in the equilibrium law. For hetero, normally we don't include solid and liquid, okay? 好，now at 950, the equilibrium constant Kc is this one. Calculate the volume of the container. Now, how do we do it? How do we do it? Now, of course, we need the ice table. In the exam, you need to write the ice table, okay, and try to insert the given information into it and see which ones are missing, and then we will be finding the missing one, okay? So now let's take a look at 2 mole, 2 mole at the beginning. So it will be 2 mole, 2 mole. Now since it's given mole, so I will use mole in the ICE table. But if you insert mole in the ICE table, after you get the equilibrium mole, you need to over volume, okay, to turn it to concentration before you put it back to the equilibrium law, okay? At the beginning is 0. Now, when the reaction attains 1.8 mole of SO3 is obtained, so it will be 1.8, okay? Now these are the given information. Then I will start filling in mine, okay? So let's see. From 0 to 1.8 is positive 1.8. Of course, the equilibrium position is shifting to the right because you only add the reactants on the left-hand side, but start with 0 product. So it will be shifting to the right so that an equilibrium can be attained later. 好，嗱 pay attention on the coefficient. Remember, as I told you, the coefficient is only applied to the change. So if this is 1.8, 2 to 1, this will be negative 0.9. Okay, because the substances on the left-hand side are consumed and the SO3 is produced on the right-hand side. And here that is 2 to 2, so it is 1.8. Okay, and then it will be 0.2, 1.1. Okay, so the equilibrium concentration for each of them will be 0.2 over V, 1.1 over V, 1.8 over V. Your task is to find out the volume, which means you have to solve V. Okay? 好，嗱 then let me form the equilibrium law first now, okay? Equilibrium law, Kc is equal to the product over the reactant. All of them are gases, so I can include all of them. Okay? Oh, then I try to insert the number. Okay? Oh, the Kc is given. It was should be right. Kc, is it given? Yeah, the Kc here, 87A in dm cube. Okay, A7A. So it will be A7A equals to this thing. Okay, I try to expand it a bit square, and here so it will be right. And then it becomes a math question, but anyway, I will do it with you. So you flip the numerator and denominator, and then you simplify it. It becomes okay. So I think you know how to do it with your calculator, right? You just put everything on the other side. So let me see. Yes, it is 11.92. So it will be in dm cube since it's given in dm cube. Any question? Any question? So basically you just have to do it like that, okay? You only have one unknown, that is the volume. So remember, in the ICE table they are mole. So I have to divide the mole by volume to find out the concentration. Okay, I still have a little bit of time. Let's just take a look here. If the above equilibrium mixture is subjected to each Le Chatelier, this is Le Chatelier. Okay. Principle. Increasing the temperature. Now, when take a look here, it's negative, means the forward reaction is negative, right? And the backward is endo, right? So if you increase the temperature, the system doesn't like it. It will favor the endothermic reaction, which is the backward. Okay, it will shift back to the left. So with the number of SO3, when it is shifting to the left, of course the SO3, the amount will decrease, right? Because an increase in temperature will favor the endothermic reaction, which is backward reaction, right? Because the forward is exo given by the delta H. Adding a suitable catalyst now. I already told you a lot of times, suitable catalyst that it increase the rate of both forward and backward at the same extent. Okay, you can shorten the time to reach equilibrium, but you cannot change the equilibrium position. Therefore, the yield Therefore, the yield doesn't change since the equilibrium position doesn't change. Okay, now I really hope that you can spend some time on this question, because for the question I gave you, I really took a look very carefully and think that you really can help you to revise the topic and learn the most out of it for that particular topic. Okay, I get back to you to explain the bond enthalpy worksheet with you later.